Okay, so I got a question from one of the tutees who had issues about the figure in the book on page 112. This is in chapter 4, which talks about recombination frequency, gene mapping, and similar topics that have to do with recombination frequency and using that to map distances between alleles and genes. So to explain this picture more clearly, I'm going to use the screen capture tool to just use my mouse. Right here you guys can see, so that I can show you clearly without just typing out a huge email to try to explain this to you guys. So one issue that I think a lot of people get stuck on is right here in the let's see, go back, is right here in the parentals to the F1. So notice these ones right here. Now the experiment, what it does is just to create two different F1s on the left side and the right side, where you see on the left side it has W plus over plus M. W is white eye, M is miniature. So if you have, what you do is you look at the top one compared to the bottom one. Those are two alleles for the same gene. So if you have one here that says W and this one says plus, then that one's going to have normal wings because this is heterozygous. And on the right side of this one is plus and M, which means it's going to have normal wings. Is it? Oh, yeah. So on the left side it's W and plus, which means it's going to have red eye because red eye is the plus, and that is wild type. And on the right side is plus and M, which means it's going to have normal wings because M is miniature, but that's masked by the dominant wild type, which is normal wings. So you use this and you cross this, you test cross it to a male that is recessive for both traits, and you get what you expect is you see this one right here cross to this one, because you're only looking at females for the results. You look at the top one that crosses to this one, and what you expect is W plus over WM. So I'll put that right here. W plus over WM. And what does that create? That creates a white eye and then a normal body. This is so slow. I'll use the text thing after that. Okay, so that one would create a white eye and normal body, just as you expect. And 50% again would go to the other side, which means this WM would go to the bottom one, which would produce WM over plus M. And let's see, WM over plus M would equal, what is that? That's a normal right here. That is a normal eyes with, because of the M, which is right here, miniature wings. So those are what we expect, and we do see the most of them. However, you do see ones that you don't expect, red eyes and normal wings, and that is because right here these crossed over, which produced a plus plus over WM. Then when the plus plus mate with the WM, that's how you get this one. So if you go plus plus over WM, that would equal normal eyes and normal wings, right? Now on this side, I told you it was plus plus over WM, and the last example I told you the plus plus was going to mate with this WM. Now this WM is going to go with the other WM. Producing white eyes and many wings. And that is what you see right here. So there's less because crossing over is always less common than not crossing over. And what this experiment shows right here, you guys can guess where everything comes from, right? You use these two, right? This one's going to cross here, produce all of the F1 that look like this. This F1 is going to cross over here. You expect most of them to be from this one to go with this one, which would lead you to the recombinant phenotype, which is white eyes and miniature wings, which are right here. See, this one's the most common in this group. And when this one goes with this one, you see normals for this one, right? Red eyes and normal wings. If this one's to cross over, then you get these ones right here, because you would get plus M and W plus. And when those go with this one, then you have white eyes, normal wings, and red eyes, miniature wings. And this is just the end result of all of this work that they did in this experiment, was just to show that the frequency of recombination are independent of whether the wild type or mutations are on the same gene or if they're on different gene. See, so they don't affect each other if they're on the same chromosome. So let me know if you guys have any questions, and I'll be happy to answer them. Alright, thanks.